Welcome students to the 10th lecture of Logic and Distributed Control System. Today we are going to discuss about the PLC timer functions. So last class we have discussed about the register basics and we have understood the different uses of registers, and today we are going to discuss PLC timer functions. And previously whatever the PLC logic using ladder diagram we have developed only using coils and contacts. So additionally with the coils and contacts we will use now timer to understand certain industrial application of PLC. So at the end of this chapter you will able to describe PLC retentive and delay time functions, list and describe 8 major timing functions that are commonly used in circuits and processes. You can apply PLC functions and PLC circuitry to process control for each of these 8 major timing functions. You can apply PLC timers in multiple timing problems that combine 2 or more of the basic timing functions, and you can apply PLC timers for the control of the industrial processes. So as an introduction, the most commonly used process device in PLC after coils and contacts is the timer. The timing block functions are used with various contacts arrangements and in multiples to accomplish various timing tasks. Typical industrial timing tasks include timing of the interval for welding, painting, and heat treating. Timers can also predetermine the interval between two operations. One major advantage of the PLC timer is that its time may be a programmable variable time as well as a fixed time. The variable time interval may be accordance with a changing register value. Another advantage of the PLC timer is that its timer accuracy, repeatability and reliability are extremely high because it is based on solid state technology. The timers are devices that count increments of time. So that is the very important thing you have to remember. Timers are devices that count increments of time. So one very prominent application you might have seen in the traffic light system. The traffic lights are one example where timers are used. In this example, timers are used to control the length of time between signal changes. You might have seen that the red signal, when it is there, then one timer counts. Suppose it is for the 10 minutes, so the timer counts the time, or it counts the increments of time. So timer is essentially an internal clock that counts in interval of 0.1 second. The number of intervals counted is called the accumulated value. So for example, when the accumulated value is 10, then the time elapsed is 1 second, because 10 into 0.1 is 1 second. So basically the accumulator value is the number of intervals, and the timer is programmed with a preset value PR, which is indicated by PR, which is the time delay, and can be any value, usually up to 999.9 seconds. There is on-delay timers and off-delay timers. Timer may also be retentive and non-retentive. So PLC timer functions. A single input timer is called non-retentive timer, is used in some PLC, as example shown in the figure. So energizing IN001 the timer to run for the 4 seconds. At the end of the 4 seconds the output goes on. So here whenever you are going to energize, so suppose IN001 is closed, then what will happen, that here the preset time has been given 4 seconds. So the timer starts to run, and after 4 seconds the TS017 is going to be energized. So at the end of the 4 seconds the output goes on. When the input is de-energized, means IN001 is de-energized, the output goes off and the timer resets to 0. If the input IN001 is turned off during the time interval, for example after 2.7 seconds, the timer resets to 0. In this case, the output would not have turned on. There are operational disadvantages of the single input type timer that are overcome by the multiple input timer. So here we are observing that whenever the IN001 is turned off, so the particular timer is going to reset to 0. So avoid this problem, we will introduce the multiple input timer. So let us discuss about the multiple input timer. The figure shows the three types of formats of PLC timers. Okay, so one, you can see that it is a block format, another is coil format, and another is coil format with separate enable and reset. But to develop any PLC programming using timer, we will use the block format of the timer functions. So this A, that is block format, is very important to understand. So here figure A and B illustrate two common types, that is figure C shows an occasionally used type where the enable and reset functions are different, are the different inputs for the use in some special cases. Okay, so here you can see that for the block format there are two inputs are there. One is run input, which is indicated by IN001, and another input is enable reset, that is IN002, and that is that's why it is called multiple contacts timer functions. And the block, you can see that two things are there. One is preset. Here preset is given 014. It means that the 14-second we have given the preset value is 14 seconds. Here the increment is assumed to be 1 second. So preset is where the timing value is set. It may be constant or designated register. And another register is indicated by HR101. The register is designated register in which the count takes place. So here basically the accumulator, which is going to increment as the time elapses. Okay, so whenever this preset value is equal to the content of HR101, then the timer is going to stop. So now how this multiple input timing format is going to work. So first of all, to make the operational the IN002, the enable input must be on. Fine. And after that, if you energize the run input, then the timer starts to increment the time, but the TS017 is not going to be energized whenever the IN001 is energized. What will happen that after 14 seconds the TS017 is going to be energized. Now in between, suppose after 8 seconds, if IN002 is withdrawn, then what is going to happen? Okay, or it is like that if suppose if TS01 means if in between after 8 seconds the IN001 is going to off, then what is going to happen? So let us discuss that two condition. So now you can see that the block format includes the enable reset line, which allows the timer to run when energized. When de-energized, the timer is kept at 0 or reset to 0. So whenever, so the answer you got, whenever this IN002 is de-energized, so then the timer is going to be reset. The upper line causes the timer to run when the timer is enabled. When enabled, the timer runs as long as the run input is energized. If the run is de-energized while the timer is running, the timing stops where it is and does not reset to 0. So that answer also you got. So suppose enable input is on, and in between when the timer is running, the IN001 is off, then the timer is not going to reset. Instead of that, timer is going to stop there. So once again, if you close the IN001, the timer going to start to count from that point of time. So note that for if both IN001, which is run switch, and the IN002, which is the enable or reset switch, open and closes at the same time, the timer function in the same manner as the timer with the single input. Suppose that IN002 is closed and the IN001 is turned on. After 6 seconds, IN001, suppose it is open. The timer retains a count on 6. The timing has not reached to the preset value of 14 seconds and the timer output is still off. The timer does not reset unless the IN002 is open. Suppose sometime later IN001 is reclosed. After 8 more seconds, the IN001 being closed, the timer coil will energize since 6 plus 8 is equal to 14. Let us once again to repeat it, that suppose the timer is suppose you have closed the IN001, and after that the IN002 is closed, which is the enable switch, and after that the run switch is closed. Then what will happen? The timer is going to start to increment its time. Now after 14 seconds, the TS017 is going to be energized. Now in between, suppose after 6 seconds the IN001 is withdrawn. Okay, it is opened, but still the IN002 is closed. Then what will happen? The timer is going to be stopped there, but TS017 it will be not energized. So again, if you reclose it, then the timer starts to count from that point of time, that is from the 6 seconds. So it will count another 8 seconds, and then it is going to be energized. Then the TS017 is energized. But in between, if you withdraw, suppose IN001 is closed, but when the timer is doing the timing operation, the IN002 is opened, then the timer is going to be reset. So this is the way the timer is going to work with the multiple inputs like run, enable, reset. And the coil format is alternate to the block format. Here you can see that in the coil format you have the run, enable, reset, and timer output. So IN07 is representing run switch, and that is RT31, and IN output is RT30, that is 31. This is actually the timer, and IN8 is representing the enable, reset, and it is also representing the timer, that is RT31. And now the output of this coil is used as a switch here as a 31, which is normally open, which is ultimately going to give you the timing output here. Okay, so same way it is going to work. Whenever your IN8 is closed, whenever the IN8 is closed, then if you close the IN7, then the timer is going to run, and after 14 seconds, what is going to happen? That after 14 seconds, the coil 31 is going to be energized. When it is going to energize, then 31 is going to close, and ultimately the output 78, which is representing the timing output, is going to be energized. But in this lecture we will use, or in this course we will use only the block format, not other formats. Okay, so let us try to understand the different other variations of the timing functions, that is on delay timers, because we understood that there may be on delay timers, off delay timers, and retentive and non-retentive. So let us try to understand first on delay timers. So now here the timer function we will understand with this ladder diagram, where you can see that 001 is the start switch, and this is the timer on delay, and preset value is 10 seconds, and the same address of the timer output has been used as a timer contact, and ultimately the output is 15. So now whenever you will close the IN001, the timer also start to count, but it is not energized. It will be energized after 10 seconds. So then after 10 seconds, what is going to happen? The timer is going to be on, means the timer contact is going to be closed, then 15 is going to be energized. So this 15, the output 15 is delay with respect to the on of the switch, that is 001. That's why it is called on delay. So delay so whenever IN001 is closed, at that moment of time the 15 is not going to be energized. Instead of that, after 10 seconds the after 10 seconds of pressing the switch 001, the 15 is going to be energized. So that's why the name has been given on delay. So that's why IN001, that is going to be on here. Okay, so at that moment of time the 15 is low, 15 is off, but IN001 is input 001 is still on, and after 10 seconds what is going to be happen, that after 10 seconds due to this timer the 15 is going to be on. So that's why when examine on instruction 001 is true, the timer counts out 10 seconds, the timer contact will then close and energize the output 15. The output is energized when the accumulated value AC equals to the preset value PR. So this is the concept of on delay timers. And then what will be the off delay timer? Now, the off delay timer will be whenever the IN001 will be off. Okay, at that moment of time the 16 is not going to be off. It will be off after the 10-second delay, or the delay what it is provided. So that's why these timers operate from when their input signal turn off, and they start to time from when the input is turned off. When the input is examined on, the on instruction 001 goes true, the output 16 is energized. So now what will happen? Now if you start IN001, okay, the off delay timer if you are using, then what will happen, that the 16 is going to be energized. Okay, so at that moment of time 16 is going to be also energized. So whenever IN001 is closed, 16 is also energized. Okay, IN001 is. So now if it is an off delay timer, suppose after 10 suppose the off delay timing function has been, preset value has been given 10 seconds, then what will happen, that whenever the IN001 is going to be off, at that moment of time the 16 output is not going to be off, it is going to be off after 10-second delay. Okay, so that's why it is called off delay, because 16 is going to off, it is going to be off with a delay function with respect to the switch 001. Whenever the switch is off, the expected thing is that the output is also going to be off, but it is not going to be off, it is going to off after a certain amount of delay which the user has provided. In this case it is 10 seconds. So this is the concept of on delay and off delay timer. So never forget it, because this will be very useful to develop the ladder programming. Now we will try to understand the retentive on delay timer, RTO, retentive on delay. So here what we are observing in case of normal on delay timers, that as long as the input 001 is on, after 10-second delay the 15 is going to be on, but after 10 seconds it is going to be on, fine, but to make the 15 on, the IN001 must be true, fine. So in case of retentive on delay timer, what will happen, that with these timers, if the input signal turns off after the timer has timed out, then the output device or the contacts controlled by the timer remain closed, that is the output remains energized. Means you see, after 10 second it is energized fine, but after 10 second when the 15 is energized, in between, means after 10 second you are finding that IN001 is going to be false. Even if IN001 is going to be false, if we are using retentive on delay timer, then the output remains will be on. But if it is a normal on delay timer, if the IN001 is going to be off here, then the 15 is also going to be off here. Okay, so this is the difference between retentive on delay timer and normal on delay timer. So here one example we will try to understand with the retentive on delay timer. In this example we have 4 rungs, and here you can see that start switch is 001. We are using retentive on delay timer whose address is 901 and preset value is 45, and assume that the unit increment time is 0.1 second. So if it is 0.1 second, so preset value is basically 4.5 second. So if you are using retentive on delay timer, how the outputs are going to be energized. Now whenever the start switch is closed, the retentive timer is going to increment its time, and after 4.5 second, what is going to happen, that the 15 is going to be energized because this is going to be closed, and the 16 is going to be de-energized. Okay, and after 4.5 second, even if the start switch is going to be withdrawn, the 15 is still to be energized and 16 will be still to be de-energized. Fine. To make the 15 on, then what we have to do, we have to make reset switch on. Then if we will make reset switch on, then timer is going to be reset. Then what will happen, the 15 is going to be de-energized, but 16 is going to be energized. So this is the way we can explain the working principle of retentive on delay timer. The explanation is given in the next slide. You can read that one. Now actually this formats what we have shown here, they are representing in general, but you will find that the manufacturer wise the format of the timers may slightly differ, but they are standardized by standard organization like IEC, already what we have discussed. So here you see the AllenBradley timer symbol has been shown. Here you can see that 2 switches are there, I12 and I17. Okay, and it is RTO, retentive on delay timer. You can see that the timer, time base, preset and accumulator value is there. So how it is going to work? Now the AllenBradley timer symbol shows the type of timer concerned, the timer addresses and the time base, and it that indicates the increments by which the timer moves to the preset value. Okay, so time base, it is 1.0. it means that the smallest increment in time will be 1 second. If it is 0.1, then it will be smallest increment will be 0.1. Fine. The preset value, so now here you can say that preset, the preset value is the number of time increments that the timer must accumulate to reach the required time delay. So here you can see that the preset value is 180, so it means that 180 seconds the time delay we want. Fine. The accumulator indicates ACC. Okay, the accumulator, here you can see the accumulator indicates the number of increments that the timer has accumulated while the timer is activated and is reset to 0 when the timer is reset. Useful if a program needs to record how long a particular operation took. Fine. So AllenBradley timers have 3 Boolean bits for the ladder logic. Here only 2 bits are shown, other bits I am going to show you. So 2 bits are EN and DN. Okay, so the AllenBradley timers have 3 Boolean bits for the ladder logic control, a timer enable bit en, which goes on when the timer accumulator is incrementing. A timer bit dn is which is going to be on after the set time delay, means when the preset value will be the accumulator value, and the timing bit, that is tt, that is on when the accumulator is incrementing and remains on until the accumulator reaches the preset value. Okay. So which goes the dn bit goes on after the set time delay. Okay, so now here in this format actually the tt timing bit is not shown, so that we will see here. Okay, which is actually representing the on delay timer. Let us see how this format is going to work. When the bit I12 is set, so remember that it is set. When it is set, the processor starts T40 and the accumulated value increments in 1 second interval because the time base is 1 second. Fine. The T40, that is T40TT, fine. T40TT means this input is set. This input is set and the output bit O13/01 means this output is set. It is also going to be high. Fine. And what will happen now while the timer is timing? When the timer is finished, that is accumulator value will be equal to the preset value, then T40TT, this is going to be 0. Okay, and if it is going to be 0, then what is going to happen? Now O13 by associated output device is also de-energized, means this O13 is going to be de-energized, and the dn bit that is represented here is set. Okay, and the dn bit, because the accumulator value is equal to preset value, so dn bit will be set, and the O013 by 2 means this output is set and the associated output device will be energized. When the accumulated value reaches 180 or when the rung condition go false, then the timer is going to be reset. So this is the on delay timer is going to work, and then similar way we can describe the off delay timer. How the off delay timer is going to work? Now bit I1210, okay, is reset. Whenever this input is reset, the processor starts time T40, the accumulator value increments by 1 second interval as long as the rung remains false. Okay, and the TT bit is set and the output 013 by 1 is set. The associated output device is energized while the timer is timing. When the timer is finished, that is accumulator value is equal to the preset value, then the TT bit is reset and the 13 by 1 is going to be de-energized and the associated output device is de-energized, and the done bit is going to be reset. Okay, done bit is going to be reset and the 13 by 2 is reset and the associated output is going to be de-energized when the accumulator value is reaches 180 or the rung goes false, then it is going to be reset. So this is the way the on delay and off delay timer is working, which is used in AllenBradley. But one thing you can remember here, no manufacturer specific discussion we are not going to do in this course. We will keep our symbol of timer will be, that is a block format, what we have discussed in this slide number 7, that is A. This is the format we are going to use to create any of the logic. This is the discussion only to make you aware that how a specific manufacturer having the timing symbol. So let us discuss some of the example. Okay, so first example about the on delay timer, and the theme of the discussion is that output B comes on at a specific set time after the output A is turned on. When the A is turned off, B also goes off. So certain industrial situation we have created. What is that? For a grinding operation on a metal part, the coolant flow on the part must be on for an interval before the grinding process starts. So when the process circuit is turned on, the coolant motor is turned on, and 8 seconds later the grinding process starts. So this is the problem statement, and it is advisable that whenever you are going to deal with the timer or counter functions, then you should draw the timing diagram, which will be helpful to you to understand the create the ladder diagram. So here it is telling that, so whenever a switch will be on, then you are finding that the coolant motor is also going to be on. So suppose this is the coolant motor, and what will happen, that the grinding motor is not going to start immediately. It is going to start after 8 seconds. So this is the, suppose if you are assuming that this is the 8-second interval of time, so here the grinding motor is going to start. Okay, so how we will develop that one? It is very simple. You see IN001, with that the coolant motor is connected, and the address of CR17 has been used as a run. This is the run, and this is the reset and enable function. Okay, so same address CR17 has been used here. Okay, and here it has been shown that the output is B. So in my opinion, better you use, suppose it is TS01. Now you use another another coil as an address of TS01 to have the grinding motor GM. So how it is going to operate? Now if the IN001 is closed, CR17 is energized. So CR17 is representing the coolant motor, and once this is energized, this is also closed and this is also closed. The timer starts to count, but immediately the TS01 is not going to be energized. TS01 is going to be energized 8 seconds later, and 8 seconds later when the TS01 is going to be energized, so TS01 is closed, means it is going to be true, then the grinding motor is going to be on. Okay, and if you withdraw IN001, coolant motor is going to be off. Once it is off, then the timer is going to be reset, means the TS01 is going to be off, and if it is off, the GM is going to be also off. So in this way we can explain the operation of the problem statement what we have formulated. Now the example of off delay, but here we will try to develop the logic using on delay timer, such that your concept will be clear. So what is the theme? Now both A and B have been turned on at the same time. Both are in operation. When A is turned off, B remains on for a specific set time period before going off. Okay, so let us create a situation. A motor and its lubrication pump motor are running. Okay, lubrication for main motor bearing are required during motor goes down. After the main motor is shut off, the lubricating pump remains on for a time corresponding to a cost down time, and in this problem the lubrication pump remains on for 20 seconds after the main system shut off. But here the condition is that you have to use on delay timer. It has been given that you have to use on delay timer to perform this operation. So here, as I told you, that it is advisable that always you should start with the timing diagram. So let us focus on the timing diagram. So we have output 17. Suppose output 17, when it is on, okay, at the same time the output 19, which is the lubricating pump, is also going to be on. Okay, and suppose the main motor is going to be off here, the output means the lubricating pump is not going to be off here, it is going to be off after 20 seconds. Okay, so now how we can develop this logic. Now let us understand that one. So here you see IN001, that is the main switch for the motor. So once it is closed, the CR17 is going to be energized, and this IN001 has been used as a normally closed switches for the run and enable reset. Okay, so whenever the IN001 is closed, so here this also will be closed. Okay, and this is going to be open, means this logic is not going to be in operation, and once this logic is not going to be operation, the CR18 is off. If the CR18 is off, then this is true. Okay, if this is true, then definitely the lubricating pump is going to be on. Once it is on, then the latching function is there, so it will be latched. Fine. Now suppose the IN001 is 0, means it is off. Once it is off, means this situation, once it is off, CR17 is going to be energized, de-energized. Once it is de-energized, then what is going to be happen, that CR17 is off at that moment of time. You see, 1 second, yes, that moment of time it is going to be off. But what about the motor, what about the timer? Once it is going to be false, then it is going to be true here. Once it is true, then timer starts timing, and what will happen, once it starts to timing, there is no effect on the lubricating pump, because still the CR18 is de-energized. Means this, even if this is going to be off due to the making 0 here, okay, due to the latching function, and the CR18 is off, the lubricating pump will be on. So that's why you will find that even if IN001 is off, the CR19, that is the lubricating pump, is still on, but it is going to be on for how long? Now after 20 seconds, the CR18 is going to be on, means it is going to be energized. Once it is going to be energized, this going to be false, this CR18 is going to be false, means CR19 is going to off here. So in this way, instead of using off delay timer, using on delay timer also we can have the situation where we need to develop the PLC programming for this kind of problem. Okay, now limited on time, that is A and B is turned on at the same time. B goes off after specific set of time period, but EA remains on. Okay, so this example is for a wood sawing operation. Suppose we are creating a situation, wood sawing operation. The sawing operation takes 4.6 seconds. During the sawing takes place, a blower to blow away the sawdust is to keep running until the operation is turned off. So both the saw, that is output, that is indicated by output B, and the blower, which is indicated by output A, go on at the same time. So whenever this operation starts, sawing operation, that is B, and the blower operation, which is indicated by output A, is going to be on at the same time. The saw, that is output B, goes off after 4.6 seconds. The blower, that is output A, continues to be run till the system is turned off by IN001. So as advisable that you should draw the timing diagram first. So that's why here you see that output, so this is the output B, which is the sawing operation, and this is the this is the operation for the blower. Okay, yes, the saw operation is B and the blower is A. So this is the blower and this is the saw operation. So once the IN001 is on, both the operations are on. Fine, and it is continued for the, means the sawing operation is continued for the 4.6 seconds, and after the 4.6 seconds the sawing operation stops, but the blowing operation continues to be stopped until the main switch is off. It is going to be on. So let us try to understand how it can be done. So whenever the IN001 is on, okay, so CR20 is going to be energized, which is representing the output A, and whenever the IN001 is on, this is going to be true, and we are using a timer whose run and enable is IN001 and IN002. So this is also going to be on, and whenever we will enable it at the same time, so it starts counting, but it is going to be, means the CR21 is going to be energized after 4.6 seconds. So that's why we have used it as a normally closed switch here. So what will happen during this time, whenever we have switch on the IN001, at that time this is false, means it is normally closed, so output B also is going to be energized. But after 4.6 seconds CR21 is going to be energized. It means that when the CR21 is true, then this line CR20 is used as a normally closed, so it is going to be false here. So output B is going to be off, after 4.6 seconds, but still the output A is on. It will be off only if we withdraw the IN001. So in this way we can achieve this function. So now the last for today's lecture, the last example we are going to solve, that is the problem statement is that is this is the example for a package dual stamping operation where stamping times are 8 and 14 seconds. When the package arrives in place, IN001 is actuated and stops the conveyor. The end is that packet, whatever the package we have, the end of the packet is stamped for 8 seconds, which is indicated by output M, and the top of it is stamped for 14 seconds, which is indicated, this operation is indicated by output N. The stamping operations are simultaneously occurring, and turning off IN001 releases the package to continue along the conveyor. So here basically we are performing two timing operations. So two timers are required to execute this function. So as I told you that you have to draw the timing diagram. Here you can see that this is the process, that is when it is on, the process switch is on. During that, what it is happened, the stamping operation at that moment of time it has been start, but the M is going for the 8 second of time and N is going for the 14 second of time, and after that it goes off. So how it can be performed? At the same time both the operation should be actuated, means both the stamping operation must be actuated. So now what we can do, that once IN001 is closed here, okay, so IN00 we are using one timer here which is for 8 second, another timer we will use for the 14 second, and we will use the logic. Okay, so now you see this is the output M and another output N I will show definitely. So whenever IN001 is closed, so IN001 is also closed here, and if we will enable at that moment of time, then you are finding that IN001 will be closed and the CR17 at that time it will be off because its preset value is 8, means after 8 seconds the CR17 is going to be on. So during the 8 second what will happen, CR18 will be energized, but the CR18 will means which is the stamping operation, it will be done for the 8 second, and after 8 second the CR18 is going to be off because after 8 second the 17 is going to be energized, which is making this logic false. Similarly, we can see that IN001 also will be on, and at that moment of time if we make IN003 also on, then what will happen, the CR20 will be energized because this is on, and this CR19 is still false. So stamping operation simultaneously you go for the 14 second, but after 14 seconds CR19 is going to be energized, which makes this rung false, means the CR20 is going to be off. So in this way we can perform the multiple timing operation where a certain logic or certain outputs must be on for a certain duration of time. So I will stop here and I will come in the next class with more example on PLC timer function. Thank you.